Hello guys, welcome to the channel H2O, the A to Z of chemistry. Today we are going to begin with lecture 9 from the course, but make sure you watch the previous ones before viewing this one. We are discussing the group 1 elements, that is the alkali metals, and in the last lecture we talked about the anomalous behavior of lithium, how lithium is different from the rest of its group members. Now lithium is different from the rest of its group members, but it has quite a lot resemblance with the next group, that is the group 2 element, that is magnesium. So today we will be discussing the diagonal relationship of magnesium and lithium, and this is going to be very important for you people. In fact, if you look at this year's JEE mains examination questions, there has been a question related to the lecture that we are going to have today, right? So JEE mains September 2020 question, there is going to be on the topic that we are discussing. So this is going to be very important for you people to understand why. First of all, lithium and magnesium, they have a similarity in their properties, and then what are the properties which are similar between the two. So I am Dr. Ritu Johar, your educator from the channel, and I hope you're going to enjoy your learning with me. So first of all, let us understand why do lithium and magnesium, they have a diagonal relationship. Why do they show a similarity in their behavior, right? So to understand that, let us look at the second and the third period elements where lithium and magnesium, they are placed. So lithium, this is group 1 element. Magnesium, this is group 2 elements. Lithium is present in the second period and magnesium is present in the third period. Let us draw all the representative elements of the second and the third period. I have not included over here the D block elements which are also present in the third period. Just remember that all the second period elements, they have a diagonal relationship with the next group elements second member, that is the third period elements. So lithium is present in second period, right? So this is going to be group number 1. And then group number 2, third period element, is magnesium. They have a diagonal relationship with one another. Then if you look at second group, we find beryllium at number 1, and the next is going to be the P block elements, group number 13. We find that the third period has aluminium, and both of them, they have similarity in properties, a diagonal relationship. Similarly, boron and silicon, carbon and phosphorus, and so on. So all of these, they have a similarity in properties. Now, why is it so? Let us understand this in respect to lithium and magnesium today, but it is going to be essentially the same that you will be finding for the rest of these diagonal relationships also. All right. So, well, first of all, just look at the size of lithium and magnesium. You will find the sizes to be quite comparable. So lithium, this has a size of 152 picometer. Magnesium, this has a size of 160 picometer. So lithium, this is going to be the largest in its own period. And as we move in a period, you know that the sizes, they decrease. And as we go down the group, the sizes, they increase. So when we are going to go from lithium to beryllium, the size is decreasing, and from beryllium to magnesium, the size is increasing. So as a result, one, you can say a size decrease, and on the other side, the size is increasing. So we find the sizes of both lithium and magnesium to be comparable, and this is going to be the similar for the rest also, right? And then if you look at their ionic sizes, Li positive, this has a size of 76 picometer, and Mg plus 2, this has a size of 72 picometer. All right. So this is Li positive, right? So, and whereas Mg is having a 2 positive charge, therefore the attractive force of the nucleus for the electrons is going to be more. Therefore, we see a more decrease in the size in case of Mg2 positive than in comparison to Li positive. And what we find as far as the electronegativity of these two, they are concerned, they are also quite comparable, 1 and 1.2, and the charge density is also going to be comparable. So what is charge density? You have studied the charge density is going to be charge upon volume, or you can say charge upon size, or you can say charge upon radius. So what we find is that in case of lithium, the charge is going to be plus, right? In case of Mg, it is going to be +2. But then there we will be finding that the charge is less, the size is less, the charge is more, the size is also more, and therefore what we find, the charge density to be comparable for both of these, and hence we find many of the properties which are related to this charge density of the two, making them have similar properties. Okay, so charge density same, therefore they are going to show a resemblance in properties. Now let us quickly look at what are the properties which are similar for both of them. So first of all, both of them, lithium and magnesium, they are metals, and in fact both of them, they are hard metals. You have studied about the alkali metals, that down the group the hardness is going to decrease. Lithium is going to be the hardest of all the alkali metals, and the comparison of lithium's hardness with magnesium, we find them to be comparable to one another. Then let us see about their polarizing power. So because the charge densities, they are comparable, therefore we find that the polarizing power of the two is also comparable. Then we have the action with oxygen. So lithium, this forms its monoxide, that is Li2O, whereas the rest of the alkali metals, they were forming peroxides and superoxides. In magnesium also we see, just similar to lithium, it is also going to form its monoxide, that is MgO. Okay, and then we have a similarity even in the reaction with nitrogen. In the alkali metals, it was only lithium which was reacting with nitrogen to form lithium nitride, and similar in its behavior is going to be magnesium. Magnesium is also going to combine with nitrogen to form magnesium nitride. Then we have the hydroxides. So we find lithium hydroxide and magnesium hydroxide both to be weak bases, whereas the rest of the alkali metals, they were strong bases. So lithium is a weak base, and similar to that we have magnesium to be a weak base. The nature of hydroxides and carbonates, so both of them, they are going to form oxides on heating. When you are going to heat lithium hydroxide, you will be getting Li2O plus water. Whereas when you will be heating lithium carbonate, again you will be getting Li2 plus carbon dioxide. Similar in the behavior is going to be magnesium. Magnesium hydroxide on heating will be giving us MgO and water, and magnesium carbonate will be giving us MgO and carbon dioxide. I'm just going to be uploading my quick lectures on the heating effects on various salts. So wherever we have a salt, and when we are going to heat it, what is going to be the product that is going to be formed? And that is going to really help you learn these all reactions very easily, all the heating effects. So please do subscribe to the channel so that you can get a notification the moment we are uploading those lectures of ours. So maybe by the time you are watching, the lectures have been already uploaded, and well, then you can check the playlist for those lectures. But those who are just watching the lectures now as they are being uploaded, please do subscribe to the channel so as to get the notification on very important lectures on the heating effects of salts that we are going to be uploading in a few days from now. The next we have is the bicarbonates. So bicarbonates of lithium, they are not solids, and similarly for magnesium also they are not solids. So do remember, I told you while we were discussing about the bicarbonates that apart from lithium, all the alkali metals, they form solid bicarbonates, and along with that it is only ammonium bicarbonate which is a solid. Rest no other bicarbonate of any metal is going to be a solid. So lithium is one exception from the alkali metals, and magnesium, this is a group 2 element, so no solid bicarbonates. Both of them will not be having solid bicarbonates. Which are the ones which have solid bicarbonates? It is going to be the group 1 elements except lithium, and along with that ammonium bicarbonate. The next we have is the nature of the nitrates. So lithium nitrate and magnesium nitrate thermal decomposition reactions are going to be the same. So this is again what I am going to give you in detail, very easy way to remember all these reactions where we are going to heat a salt. the thermal decomposition of these salts. All right. So please do remember that lithium nitrate is going to give lithium oxide, NO2 and oxygen, and magnesium nitrate on heating also is going to give magnesium oxide, NO2 and oxygen. So the products are the same. Lithium nitrate giving its oxide, NO2 and oxygen, magnesium nitrate giving its oxide, NO2 and oxygen. Okay. And the rest of the alkali metals we have studied, they are going to form the corresponding nitrite, and along with that oxygen is going to be evolved. So this was the difference of lithium with the rest of the alkali metals, and it is similar in its behavior with magnesium too. The next we have is the solubility of fluorides, carbonates and phosphates in water. So this is going to be insoluble because of high lattice energy. Similarly, the magnesium, fluorides, carbonates and phosphates, they are also insoluble because of high lattice energies. The solubility of chlorides in organic solvents like alcohol and pyridine, both of them, lithium chloride, magnesium chloride, they are soluble in organic solvents. Hydration, we find lithium is chloride is deliquescent. It can absorb moisture from the air and get converted into the solution form. This is because of the high hydration energy of the lithium ion, and it is because of this we find that the lithium salts, they are hydrated. For example, for lithium chloride, it is lithium chloride 2H2O. Similarly, we have magnesium chloride also to be showing similar properties, because again the charge density for both of them, this is going to be the same. The hydration or the magnesium ions is also going to be the same. All right. So these are a few properties which are similar for lithium and magnesium. In fact, they are not few, quite many properties for lithium and magnesium which are similar to one another. So now it is going to be time for the lecture review questions. So these are the lecture review questions which I post at the end of every lecture, so that you have an understanding what type of questions they do come in the examination. The last lecture I did not post any question because it was a very small topic. So I have combined these two lectures for the 3 lecture review questions that I will be giving today, and you have to post in your answers in the comment section. Only then I will be giving you the correct answers, right? All right. So the first question we have is, for the last lecture, which of the following are the correct reasons for the anomalous behavior of lithium? Exceptionally small size of its atom, its high polarizing power, it has high degree of hydration, exceptionally low ionization enthalpy. And this is a question which has been given in the NCERT exemplar book, and this has multi-correct options. So please be very careful while taking the correct options. All right. The next question, this is a NEET 2017 question. Both lithium and magnesium, they display several similar properties due to the diagonal relationship. However, the one which is incorrect is both form soluble bicarbonates, both form nitrides. Nitrates of both lithium and magnesium yield NO2 and O2 on heating. Both form basic carbonates. One thing very importantly I would like to tell you over here is these heating effects of all the metal salts. This is very important. In one way or the other, they do come in all the competitive examinations. So please do not miss the lectures that I'm going to just now be putting up for you. I'm just preparing those lectures, and they will be available very shortly for you people. The next we have is two elements A and B. They have similar chemical properties. They don't form solid hydrogen carbonates but react with nitrogen to form nitrides. A and B respectively are lithium and magnesium, cesium and barium, sodium and rubidium, sodium and calcium. So for today's lecture, this is going to be a very easy answer. But when it is going to be a compilation of all the inorganic chemistry and being asked in JEE Mains September 2020 examination, it makes it important. So that would be all for this lecture. I hope you've enjoyed your learning with me. You understood everything very well, and you will remember all these very similar properties of lithium and magnesium. And obviously, I am waiting for your answers in the comment section. This is the only way I come to know how much you are gaining from our lectures. Although you can put your suggestions also in the comment box, whatever more you want from us. But please make sure that you answer each and every question that we are putting in the lecture review questions. So see you again. Have a nice day. God bless you.